Hey guys, this is your trainer Anirudh Chhillar. So I'm back with another video of EIGRP. I hope you're learning in a good way and in good pace. Let's go.
Fine. Today, first of all, I'll teach you use of offset list in EIGRP. So in EIGRP, remember that we cannot use offset list to perform route filtering like we use this offset list in RIP. In RIP, I taught you that how can you use offset list to perform route filtering. But in EIGRP, it is not possible to use this offset list to perform just route filtering. Here in EIGRP, you can use this offset list just to manipulate your path selection in EIGRP. Like for an example, for R5 might be the best path to reach the loopback of R1. I mean the lane network of R1. Its best path is via R4. With using offset list, you can make it via R3 or via R2. Sorry. Are you getting my point or not? Let's say for R5, the best path to reach the loopback of R1 is via R4. But if we was to make it via R3, then we can also use offset list. I mean, here in EIGRP, you will be using this offset list just to manipulate your path selection. You can also use this offset list in another way as well, like just to perform equal cost load balancing. Just to perform equal cost load balancing, because sometimes what happens, let's say that let's take an example again of R5. R5 is receiving the loopback of R1 from its neighbors R4 as well as R3, but by default its best path is via R4 only, so it is not going to install route via R3 in its routing table due to metric only, right? Because via R4 it is having its successor and via R3 it is having feasible successor. So without using variance command, it's not possible to install your feasible successor in your router's routing table. Is it possible? No. But with using with having or with configuring offset list, you can achieve it. What can you do? Actually, with using offset list, again you will be adding your metric. You cannot reduce your metric, but you can add some more metric with using offset list, because the meaning by offset is what? Just to adding. So you can add metric by using offset list here in EIGRP. So you do one thing, because for R5, I mean in perspective of R5, the total metric to reach the loopback of R1 is lower via R4 rather than via R3. So do one thing, with using offset list, increase its metric via R4, so that the metric via R4 as well as via R3 to reach the loopback of R1, the metric will become same via R4 as well as via R3. Once the metric will become common to reach the loopback of R1 via R3 as well as via R4, then your router R5 will start to perform equal cost load balancing. I hope that you have understood it now. So with using offset list, you can achieve equal cost load balancing. The second task, you can also manipulate your best path selection. Might be that the best path to reach, I mean from R5, the best path to reach R1 is via R4, but you want to reach it via R3. You do one thing, with using offset list, just increase its metric via R4, so that the metric via R4 will become higher than via R3. Once the metric via R4 to reach loopback of R1 will become higher than via R3, then definitely for R5 its best path will become via R3. This is the only uses of offset list. Again, there is very simple definition for offset list, just to increase your metric. Now you know very well that why would you require to increase your metric, right? So accordingly you will take decision, accordingly you can configure offset list. But here remember that you cannot perform filtering with the help of offset list. Let's do it now. Let's move on R5. Let's check for the loopback of R1. Show IP route 150.1.0. Check it out. So its best path is via 45.4. Now let's check its topology table as well. Show IP EIGRP topology 150.1.1.0. Then its subnet mask. You will see that it can reach it via, that's fine, via R4. It can also reach it via R3, and as well as it can also reach it via R2. So might be via R4 it's having its successor, via R3 it is having feasible successor, whereas via R2 it is having possible path. Now what I want, that for R5 its best path to reach the loopback of R1 must be via R3 only. It should not be via R4. So let's make it now. We know very well the total metric to reach this loopback of R1 via R4 is 232, 34, 56. Whereas via R3 it is 23, 74, 656. So what's the difference? We can use calculator to calculate this difference, right? So higher value is what? 23, 74, 656 minus 232 and then 34. So it is 51200. So let's do one thing. Let's add 61200 via R4. Let's add, because you have to add some more metric, right? If you add only 51200, then it will become same and it will start to perform equal cost. But if you add 51201, then its best path will become via R3. Let's do it now. To configure offset list, rules are still same as RIP. There is no difference in the configuration of offset list in RIP and EIGRP, right? The configuration is same in RIP as well as in EIGRP. So first of all, you have to create an access list. One commit 150.1.1.0, then it's wildcard mask, and then go to router EIGRP 100 and then say offset list. Then it will ask about your ACL, it was 1. Then it will ask about in or out. So of course this prefix is what? Incoming prefix. It's not going out. However, in EIGRP also you can configure your offset list in both directions. You can also configure it in outbound direction as well. So offset list 1 in, and then you can add that metric here, which is 51201. 51201. Now remember, do not add or do not press enter here, because if you press enter here, this, and in that case this offset list will be applied on all interfaces for their incoming updates. So because you wanted to add it via R4 only, so you have to apply this offset list only on serial 0 by 1. So move on R5 and apply it only on serial 0 by 1. Now you will see that for R5 its best path will become via R3 automatically rather than via R4.
अपने यहाँ इन पे लगा दूसरे इन पे ना आउट पे लगा रखी है पॉलिसी, तो कौन सा पॉलिसी? फॉर एग्जांपल मैंने रिप की बात कर रहा हूँ, तो रिप में मैंने एक साइड में ऑफसेट लिस्ट में जो
Fine guys, so now you can see that on R5 its best path have become via R3, you see, and if you trace route it 150.1.1.1 definitely will go via R3. So in this way you can modify your best path selection with using offset list. Now if you wanted to perform equal cost load balancing, because we knew that the difference in between their metric is 51200, so you do one thing, because we knew that the metric to reach the loopback of R1 via R4 is lower than via R3. So we just need to add 51200 metric via R4. So do not add 51201, right? So let's move again back on R5, do show history, as here I added how much? 51201. So remove it and in place of 1 make it 0. So now you will see that via both neighbors its metric will become same, and now it will start to perform equal cost load balancing. So remember that unequal cost load balancing can be achieved with the help of variance value. You cannot achieve unequal cost load balancing with using offset list. With using offset list you can achieve only and only equal cost load balancing, because the meaning by equal cost load balancing is what? Like it will perform load balancing equally, right? It will perform load balancing equally. Whereas in case of unequal cost load balancing means load balancing will be done unequally. Like in previous class I told you that okay, load balancing should be done in ratio of 1:2. So that is not possible to achieve in case of or with the help of offset list, I mean without using variance, you cannot achieve unequal cost load balancing. So might be that you have heard it before that with using offset list we can also achieve unequal cost load balancing, but it is not possible to achieve unequal cost load balancing without using variance. So this time again you will see that what is the best path to reach the loopback of R1. So this time you can see that via R4 as well as via R3 it's having equal metric, that is why it is performing now equal cost load balancing. Show IP route you can see here, and for the loopback of R1 you will see that it is performing equal cost load balancing. Even you can also perform trace route here 150.1.1, you will see that traffic is going in both direction, in the direction of R4 as well as in the direction of R3, and then finally it is reaching R1. Have you understood it now? Tell me. So in this way you can use offset list in EIGRP, but again I am repeating my line that in RIP it was also possible to perform route filtering with using offset list, but here in EIGRP it is not possible to perform route filtering with using offset list. Fine. After going through this offset list, I've removed this offset list from here, and again for R5 its best path will become via R4 only. You see it have become now. To reach the loopback of R1 its best path is now via R4 only. Fine. Let's talk about administrative distance values in EIGRP now. You know very well that in EIGRP we are having three types of different AD values for different types of routes. For internal prefixes it's by default 90, for external prefixes by default it is 170, and for summary addresses for summary routes it is by default 5. I'll teach you all these things, that why is it necessary to configure its AD value as 5 for its summary address. I'll teach you, don't worry. But right now I'll simply show you that how to modify, how to manipulate your administrative distance value, right? How to change your administrative distance value and how to manipulate your best path selection in EIGRP with using administrative distance value. And remember that AD value comes before than metric. Metric will always be compared if your AD value is common. So this time for R5 you see that for R5 its best path to reach the loopback of R1 is via R4. We want to make it via R3, and we know very well that via R3 as well as via R4 its AD value is what? 90. So you do one thing for this special, for this prefix only, change your administrative distance value and configure it higher than 90, so that the AD value to reach this prefix will become higher via R4 than via R3, because via R3 still its administrative distance value will remain as 90. So make it either 91 via R4 or make it 89 lower than 90 via R3. So you can also manipulate it in this manner. To achieve it, what can we do? And also it will also also we will prove that this AD value will take place first than metric. It will compare administrative distance value first rather than comparing metric. So on R5 you do one thing, because this time I just wanted to change it for 150.1.0. So do show IP access list. First of all let me check this ACL. Yeah, ACL is already there, right? Now you do one thing, router EIGRP 100, you know very well distance. Here we are having two different things. One, like distance EIGRP, then it will ask for internal routes which is by default 90, you can make it 70, and then it is asking for external prefixes, let's make it 150, and then you can press enter. Now what will happen, that for this router, for all prefixes, for all internal prefixes AD value would become 70, for all external prefixes its AD value would become 150. And if you don't want to change its AD value for external prefixes, then leave it as default, which is by default 170. So you can also configure this command, but it is mandatory, it is compulsory in this command to specify the AD values for both types of prefixes, for internal as well as for external. Otherwise your command, your command will remain incomplete if you do not specify both AD values. AD values for both type of routes. Fine. Then after you do one thing, this was that how can you manipulate your administrative distance values for all internal prefixes as well as for all external prefixes. Rather than changing your AD value for all internal prefixes as well as external prefixes, you can also modify administrative distance value for a particular prefix as well, from a particular neighbor as well. Means per prefix per neighbor. You can modify your administrative distance value per prefix per neighbor. So let's say distance, let's say I wanted to configure it as 65, or you can make it 91 as well via R4. So you do one thing, you said distance 91, now it is asking about its source. So from where you are getting all these prefixes, 155.1.45.4, because R4 is having this IP address. So we were having this prefix, we were receiving that lane network of R1 from R4 with lower metric. Now I'm gonna to manipulate this path selection by modifying its AD value. So this time say distance 91 155.1.45.4, because we are receiving it from this neighbor only. Then it is asking for wildcard mask. So because we are having only this dedicated neighbor, so I will specify my wildcard mask as 000, and then after you see that it is asking for ACL. Even you can also press enter here without specifying your ACL as well. So if you do not specify your ACL, in that case it will change its AD value for all those prefixes which are coming from this particular neighbor. But I just wanted to change its AD value only for that specific prefix, which was the lane of R1. And the lane of R1 is what? I have already called that lane in ACL 1. So here I have called that ACL 1 now. So what will happen, what is the meaning of this command? That it will configure its AD value as 91 whenever it will receive prefixes from this particular neighbor which will match with this ACL. So it will change its AD value only for those prefixes which are matching with this ACL. So now let me show you show IP route for 150.1.1.0, and now you can see that this time its best path have become via, tell me. So before metric it is comparing their AD values, is not it? And to check your configuration of AD value, you see run this command show IP protocols, and you will see that distance by default is 90 for internal prefixes, for external it is 170. But when source is this and ACL is this one, in that case its distance value will become 91. So I hope that now you have understood it, that how to modify, how to manipulate your path selection by changing its AD value based on per prefix per neighbor. So this is that how can you manipulate your path selection by modifying administrative distance value. So is there any problem now? If you are having any problem in this command or in this concept, please let me know. Otherwise we can go for next topic now. It's same as RIP. There is no single difference in modifying its AD value or in manipulation of best path selection in between RIP and EIGRP with using administrative distance values. And also you can filter it. If you wanna filter it, then also you can achieve it. Like for an example, this time if you move on switch 4, you will find all prefixes coming here, right? Let's say that I want to filter any specific prefix. Let's say that I want to filter the loopback coming from switch 3, which is 150.1.9.0. So you do one thing, create another access list 10, permit 150.1.0, 9.0, and then it's wildcard mask, and then say router EIGRP 100 distance is 255, and then it will ask about your source. So source is going to be 108.8 because you are getting all prefixes coming from switch 2, and then after you can specify its wildcard mask, and then after you can also specify your ACL, which was 10. So this time it will configure its AD value as 255 for those prefixes which are matching with this ACL and coming from this particular neighbor. Show IP route. Let me show you once again its routing table, and this time you must not be able to get the loopback of Swiss 3. Is there? 9.0? Of course no. And if it is not there, and if you try to communicate with 150.1.9.9 now, so definitely you cannot communicate with this loopback of Swiss 3 because this route is not available in our router's routing table. So now router EIGRP 100, and just go and remove this command once again. So I have taught you that how to modify, how to manipulate your best path selection with using administrative distance value, and also how to perform route filtering with using administrative distance value. So if you are having any problem related to administrative distance value or use of, with use of administrative distance value in EIGRP, please let me know. Understood or not? Fine. So this is the uses of administrative distance value. Now let's talk about summarization as well. You can also perform summarization in EIGRP. Router EIGRP 100. Let's remove this previous command from here. And you know very well that because EIGRP also comes under distance vector routing protocol, and as I said earlier on, that in all distance vector routing protocol you can configure summary address anywhere in the network on any router. So same as RIP, in EIGRP also you can configure summarization on any router. So once again, let's do one thing. Create some loopbacks on Swiss 3 in range of 90.1.0/24 to 90.1.5.0/24. So you do one thing, move on Swiss 3, create loopback 1, IP address 90.1.1. Even I will create 7 loopbacks. Fine. And then you will require to advertise them into EIGRP, and command will be 90.1.0.0, and I hope that you can understand it very easily. The meaning of this command 7.255, it means that EIGRP will get enabled only for these networks, not for any other. Like if any loopback is having 90.1.8.1, will it be really possible to enable EIGRP with using this command on that interface? Of course no. EIGRP will not get enabled on that loopback which is having an IP address like 90.1.8.1, because 90.1.8.1 will not come under this range. Have you understood it or not? So after running this command, let me show you show IP EIGRP interfaces, and at that moment, now in the result of this you will come to know that okay, EIGRP has enabled on all these loopback interfaces. And now on switch 4 you must be able to see all those prefixes, and all of them are coming individually, right? So if you want to reduce the total number of routes available in your router's routing table, then you can perform summarization. As I said earlier on, that in EIGRP it is possible to configure summarization on any router, but here it is always recommended. It is always recommended to configure summarization near to source. So where is our source? Of course Swiss 3. Near to source. Who is originating all these prefixes? Who is advertising all these prefixes? Of course Swiss 3. So it will be better for you, or it will be best place to configure summarization in this network, right? However, it is not mandatory. Even you can also configure it on R5 F0/0, because R5 is also advertising all these prefixes out from F0/0 individually. So you can also configure summarization on R5's F0/0. Or you do one thing, configure the summarization on R3's S0/0, R2's S0/0, as well as R6 F0/0, so that whenever R6 R3 and R2 will advertise all these prefixes towards their neighbor, then also they will give it in summary form. I mean, they will also advertise only and only summary address, right? Or do one thing, configure summarization on switch 1's F0 by 1 or F0 by as well as F0 by 0. So that now switch 1 will also advertise only and only summary address. But now you have seen it, you have observed it that if we are configuring summarization on any other router rather than configuring it on its advertising router, might be we will require to configure multiple summary command on multiple interfaces. It's not it. Like if you configure it on switch 1, then of course you have to configure it on FA0 by 0 as well as FA0 by 1. And if you do not follow this rule, then your entire data flow will get changed. Because let's say that you have configured this summary address only on FA0 by 0, you didn't configure it on FA0 by 0. So whenever switch 1 will advertise all these prefixes, all of them will go individually out from FA0 by 0, but out from FA0 by 1 it will advertise only and only summary address. So for all other routers, their best path will become via R6 only. You know why? Because via R6 they will keep on to receive all these prefixes individually on /24, whereas via R3 they will be receiving it on /21. I mean, they will be receiving it as a summary address, right? And based on longest prefix match, because before metric and AD value they will compare their longest prefix match. So based on longest prefix match for all routers, for all lane users, their best path to reach all these 90s prefixes will become via R6. Are you getting my point or not? So whenever you are going to configure summarization in your network, please be careful, because if you do not configure it carefully, it might be that your entire data flow will get changed. Even you can check it out, like from switch 4 you can trace route 90.1.1.1. fine, it is going through the best path, like switch 2, R5, R3, switch 1 and finally switch 3. Means it is going in this way: switch 4, switch 2, R5, R3 and then switch 1 and finally switch 3. But if you configure summarization on switch 1 0 by 1, let me configure it on switch 1 0 by 1. IP summary address EIGRP 100 and then 90.1.0.0.245.245.248.0. That's fine. So this time this switch 1 will advertise only and only summary address out from this interface. And now you will see that for all 90s prefixes, the best path from switch 4, I mean you can trace out it from switch 4, you will see that now it is going via R5 and then R4, then R6, switch 1 and then finally switch 3. Is not it? You can trace route any 90s raised prefix like 90.1.2.1 as well. So for all 90s prefixes, its best path will become via R6. So that's why I said that if you are going to configure summarization, please be careful before going to configure your summarization, because due to summary only, due to summarization, your entire data flow can get changed. So please do it carefully. Configure it carefully.
So that's the end of today's video, guys. So we'll be coming back with few more videos of EIGRP. I hope you learned something new today. So if you like this video, please subscribe my channel. That's @ARC_tutorial. Thank you so much, guys. See you later.